Alright, so the problem is called add two numbers. It's a medium problem. So we are given two non-empty linked lists representing two non-negative integers, and their digits are stored in reverse order. What does reverse order means? This means that this number is actually 3, 4, 2. Because you see it's reverse. The reverse is that it's denoted as linked list 2, 4, 3, but it's actually 3, 4, 2. And then we need to add the two numbers, and return the sum as a linked list, also as a reversed order. And you may assume the two numbers do not contain any leading zero except the number 0 itself. So let's see what we have here. We have basically two linked lists. You see, two linked lists. We need to traverse them. This is called L1 and this is called L2. We need to traverse. How do you traverse a linked list? You just put the current node. Let's say we are at L1 dot next. Okay, this is the basics of the traversal, and their value is stored in the val variable. Once we traverse these two nodes, then we need to add it to a summary. So let's say that we have 3, 4, 2, and let's take the nodes. We have here 2, 4, 3, and also 5, 6, 4. And we start adding them from the first node. So this is the least significant digit. 2 plus 5 is 7, 4 plus 6, oops, so we need a carry. So we also need a carry variable, which is going to be an integer. Store here in the carry this 1, and next, the important thing is, whenever we add items, we also add the carry. So that the result of this would be 8, and the actual number is 807. This is the actual result. So we need to go with next. We need to use the val. We need to scan both lists and check, scan them until the end. And we need to use the carry all the time. And we need to create a new list node for the result, because the result is also going to be a linked list. And note that when we finish scanning all the items, we might have a carry from the last item. So after we finish this loop of scanning the items, we need to check if we have something in the carry, and if yes, we are going to add it to the result. Okay, so let's start coding this. So as you see, I started here by defining the head. We need the head because we are returning an output list. And how do you return a list? You return a pointer to the head of the list. The current is going to be the current node that we are currently having in the summary in the output. And this is the carry. The carry is just an integer which first is pointing to 0. So we start by iterating both lists. In case any of the nodes, so we have basically a few stages. One stage is to prepare the input nodes. We want to check that none of them is null. Next is to calculate the sum. This is going to be step 1. In step 2, we calculate the sum. In step 3, we are going to prepare the output. Actually, take the sum, create a new node, and add it to the output list. Prepare output node and output node, and it would point to the summary, point to sum. Okay. Last, we prepare for the next iteration of the loop. So move step 4 is going to be move to next node, and after we finished with this, we said that we might have still something in the query, so finished looping, having something in query, add it to result as a new node, and then just return the head, because this is the output. This is step 5. Alright, so let's start preparing the input nodes. How do we prepare the input nodes? We check if any of them is null, and if yes, we can just do a cheat here and say that it's not a null, it's 0. And the same for node number 2, if it's list number 2, if it's null, cheat and say that it's just a 0. It's the same effect, only we avoid here the null. Now we need to calculate the sum. How do we calculate the sum? So the total, or the sum, is L1.value, and see here, because of our cheat, if any of them is null, then we would get 0, which is perfectly fine. The sum is L1.val plus L2.val plus the query, which is initially 0. So we added the query, but if our total now is larger than 10, larger than 9, then we need to calculate a new query. So the new query would be total divided by 10. And the actual value that we need is not this total. Okay, this is not the output of the two nodes that we see here. This total is the grand total including the query, but when we add the two nodes, then the sum is only the number up to 10. So the actual value, yes, is the total mod 10. This is the actual value. Okay, so we made the calculation. We made step 2. Now let's move on to step 3, which is preparing the output node. So if we prepare an output node, how do we prepare? You first create it. So let's create the output node, new list node. We have created it. What is the value of this node? It's v. New node.val is v, the number without the query. However, we created a new node. But what about the head, and what about the current? We didn't even say. So if the head is still null, then this is the head. If head is null, and you see we have here a pattern for managing list. When you create a new list, you need to create a new node, check if the head is null. If yes, apply this node to the head. If not, apply this node to the next node. So if head is null, then the head is the new node, is our node. And we are going to need to traverse to the result. So current is pointing to the head now. If we already had a head, then actually it's not going to be the head or the current node that we are adding. It's actually going to be the current.next node, because we already had any node. This is going to be the new node. Okay, so either the node is the head or the new node is the next node. And what is the current for the next iteration of the loop? The current is current.next. We move the current node, so we prepare the output node and we move on to the next node in the output. Okay, in the output node. Okay, now that we finished with it, let's move on to step 4, which is just to prepare us to move to the next iteration on the input. L1 is L1.next, L2 is L2.next. So if you ask yourself, how come we move to the next node only if the head is not null? because you see when the head is actually null, we set the current to the head, and on the next iteration the new node is going to be the next node. So everything is perfectly fine. And when we set the current to the next node, this is like the current node. The current node that we added is the next, and before that the current node that we added is the head. So here we set actually the current node, which is either the next node that we just added or the head node. Let's try submitting it, and let's omit this case without the last carry if it wasn't that clear. Let's see what this means. So we try to submit this. Okay, and this is good. You see, even without the latest section of finish looping and checking if there is a carry, but you'll see that if the last digit has another carry, then we didn't handle it because we were only in the loop. Okay, loop number 1 add these two, loop number 2 is these two, loop number 3, and finished. But if here we have a carry, then we are out of the loop and we need to add a carry. If we submit, we'll see this case exactly. Okay, wrong answer. Why? Because you see this was our output. However, we had another carry at the end, so we need to treat it. So how do we treat the last carry? Simply, if we have any carry which is larger than 0, then current.next, which is the current node that we just added, is a new list node that has only the carry, because this is the only thing that we have on the last carry. So let's now submit it. Then no need for this. Okay, and we have another issue. Let's see what is it. So actually the problem is here because we said while L1 is not null and L2 is not null. Okay, so you see, so we didn't like enter the last iteration. We need to check if any of them is not null, and if any of them is not null, then set the one that is not null to 0. So let's try this again. Or L2, another issue. So if any of them is not null, continue with the loop, but the one that is null, set it to 0. Okay, so this is pretty good. Let's recap what we had here. We had a linked list that we return as an output. So we have both the head of the output and the current node. Then scan the linked list. Check if any of the nodes is not null, and if not, then prepare the other one to be 0. Calculate the sum. The total is the L1 plus L2 plus the previous carry. Calculate the new carry. Calculate the value without the carry, and then prepare the new node. The new node is just a node with the value. We could also have here V instead of the next line. Not that important. Then if the head is null, set the new head. And if the head is not null, set the next node. Then move on to the next loop iteration to prepare for the next loop. And at the last phase, we check if the carry is not empty or 0. If it's not 0, this means we have a carry from the latest addition, so we need to add it. So this was very helpful because we scanned here how to go through a linked list, how to prepare a linked list, the head, the current, how to iterate items, a few tricks about the while loop, and the fact that we can create one of the nodes as 0 if one of the items is, in a lot of cases you have two lists or multiple lists, and you need to iterate until the end. So either you have indexed out of bound exception if you check one of them. So here what we say that let's move on until the end in one of the lists, and if the other list is finished, init it to some default value. So I think this was very interesting, and see you next time.